Hello and welcome back to Chopstick Maths. In this video, we shall be solving sum number 3 from exercise 4. We will be finding the solution to this given differential equation 2xy square minus y dx plus x dy is equal to 0. And let us call this as equation 1. Now we'll have to first find out if this given differential equation is an exact differential equation or not. So let us compare this given differential equation with m dx plus n dy is equal to 0. And on comparing we get m is equal to 2xy square minus y and n is equal to x. Now we will have to differentiate m partially with respect to y and then differentiate n partially with respect to x. And if del m by del y is equal to del n by del x, then we can say that the given differential equation is an exact differential equation. So let us now proceed to find the partial derivative of m with respect to y. That is, del m by del y is equal to 2x del by del y of y square. Now whenever you're differentiating partially with respect to y, you have to treat x as a constant. So here this x would be treated as a constant and 2 is a constant. Therefore 2x will be a constant and it will be written outside. So this would be 2x del by del y of y square minus del by del y of y. Now del by del y of y square is 2y. So this would be 2x into 2y minus del by del y of y is equal to 1. So this would be minus 1. Therefore del m by del y is equal to 4xy minus 1. Now n is equal to x and we'll have to differentiate n partially with respect to x. So del n by del x is equal to del by del x of x. Therefore del by del x of x is 1. Therefore del n by del x is equal to 1. And now we can clearly see del m by del y is not equal to del n by del x. Hence the given differential equation is not an exact differential equation. Now that this given differential equation is not an exact differential equation, we will have to find a suitable integrating factor such that when we multiply this given differential equation with that integrating factor, then this given differential equation will be reduced to an exact differential equation and we will be easily able to find the solution for the given differential equation. Now if del n by del x minus del m by del y upon m is a function of y only, say f of y, then the integrating factor is equal to e raised to integral f of y dy. Now del m by del y is equal to 4xy minus 1 and del n by del x is equal to 1. Therefore del n by del x minus del m by del y upon m is equal to 1 minus into bracket 4xy minus 1 upon m is equal to 2xy square minus y. This would be equal to 1, and now since there is a negative sign outside the bracket, so when we open this bracket, the terms inside would change their sign. So this would be minus 4xy plus 1 upon 2xy square minus y. Now 1 plus 1 is equal to 2 minus 4xy upon, in the denominator we can pull the y common outside. So the denominator would be y into bracket 2xy minus 1. Now in the numerator we can pull out the 2 common. So this would be 2 into bracket 1 minus 2xy upon, and in the denominator we will reverse the order of subtraction. That is 2xy minus 1, we will write it as 1 minus 2xy, and this can be done by writing a negative sign outside the bracket. So the denominator would be minus y into bracket 1 minus 2xy. Now the term 1 minus 2xy will cancel out in the numerator and the denominator. And we will be left with minus 2 by y. That is del n by del x minus del m by del y upon m equals to minus 2 by y. So this is a function of y only. Let us say f of y. Therefore, the integrating factor is equal to e raised to integral f of y dy. Now, let us substitute the value of f of y in the integral, which is equal to minus 2 by y. Therefore, the integrating factor would be e raised to integral minus 2 by y dy. Now, we can pull the minus 2 sign outside the integral as minus 2 is a constant. So, the integrating factor would be e raised to minus 2 integral 1 upon y dy. Now, integral of 1 upon y dy is equal to log y to the base e. So, the integrating factor would be e raised to minus 2 log y to the base e. And we can now simplify this integrating factor by using the property of log, which says that m log a to the base e is equal to log a raised to m to the base e. So, we can write the integrating factor as e raised to log y raised to minus 2 to the base e. And we can further simplify this integrating factor by using another property of logarithm, which is e raised to log f of x to the base e is equal to f of x. So, e raised to log y raised to minus 2 to the base e is equal to y raised to minus 2, which is equal to 1 upon y square. Therefore, the integrating factor is equal to 1 upon y square. Now, multiplying equation 1 by the integrating factor 1 upon y square, we get 1 upon y square into bracket 2xy square minus y dx plus 1 upon y square x dy is equal to 0. So, this would be 2xy square upon y square minus y upon y square dx plus x upon y square dy is equal to 0. Now, here in the first term, the y square gets cancelled in the numerator and the denominator. So, what would be left is 2x minus, in the second term, the y would get cancelled in the numerator and the denominator. So, this would be minus 1 upon y dx plus, now here there is no factor common in the numerator and the denominator. So, we will have to write this term as it is. So, this would be plus x upon y square dy is equal to 0. And let us call this as equation number 4. Now, equation 4 is obtained by multiplying equation 1 by the integrating factor 1 upon y square. Therefore, the equation 4 is an exact differential equation. And the solution to the exact differential equation is integral m dx keeping y as constant plus integral n dy and integrating only those terms from n which are free of x is equal to some constant c. Now, here m is 2x minus 1 upon y and we have to integrate m with respect to x treating y as constant. Now, the first term is 2x. Here 2 is a constant, therefore, we will be writing 2 outside the integral sign. So, this would be 2 integral x dx minus, the second term is 1 upon y and we have to treat y as a constant. So, we will have to write 1 upon y as a constant. So, we will have to write it outside the integral sign. So, this would be minus 1 upon y integral dx. Now, here we will have to integrate n with respect to y and integrate only those terms from n which are free of x. Now, here n is equal to x upon y square and we can see that there is an x in the numerator. So, we will have to neglect this term. So, this would be 2 integral x dx minus 1 upon y integral dx is equal to some constant c. Now, integral x dx is equal to x square by 2, and we have integrated this using the formula integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So this would be equal to 2x square upon 2 minus integral of dx is equal to x. So this would be minus x by y is equal to c. Now this would be x square, as 2 would cancel out each other in the numerator and the denominator. So this would be x square minus x upon y is equal to c. Now taking the LCM, we can write x square y minus x upon y is equal to c. And we can write this as x square y minus x is equal to cy, which is the solution to the given differential equation. Thank you very much for watching the video, and if you have liked the video, then please do consider subscribing to the channel. See you in the next video. Bye for now.